So in Google Classroom, under the Chapter 5 heading, you will see the Chapter 5 Identities handout. That's what this piece of paper is. If you don't have a printer, you can write these down. A lot of these you're already going to know. The whole first half of the first page, we've already seen and we've already talked about. We have what are called the reciprocal identities. It tells us that sine is the reciprocal of cosecant and vice versa. Or either one of these, if I multiply it, I get sine times cosecant is equal to 1. So it's just a different way of looking at the same thing. Cosine is the reciprocal of secant. Again, two different ways of looking at the same thing. And tangent is the reciprocal of cotangent. Two different ways of looking at the same thing. The quotient identities. Tangent is sine divided by cosine, or the reciprocal, cotangent, is cosine divided by sine. In section 4.1 in the homework, one of the homework assignments was actually for you to prove that this is true. Sine squared plus cosine squared equals 1. It was done a number of ways. It could have been done using the Pythagorean theorem. It could have been done using opposite over hypotenuse and adjacent over hypotenuse. Either way, this is the Pythagorean identity. Sine squared plus the cosine squared equals 1. All the rest of these are derived from this one, okay? And so they're just on here so that you can have a visual to see different ways that this is represented. If I take this one and I subtract cosine squared, I get this one. If I take this one and I subtract sine squared, I get this one, okay? If I take this one and I divide everything by cosine squared, I get this one. If I take this and I divide everything by sine squared, I get this one. And then these two, again, are just variations of this one. This one we subtracted 1. This one we subtracted tangent squared. Here we subtracted 1. And here I subtracted cotangent squared. All of these come from this one, okay? Also, way back in 4.1, we talked about cofunctions. We talked about cofunctions, and we had all those sines and cosines on the board, and we talked about how the sine and the cosine of complementary angles are the same. So the sine of 60, the cosine of 30, okay? And so that's where these came from. And so sine of 60, cosine of 30, okay? And we can do it in degrees. We can do it in radians. We can flip-flop it. It's the same thing. Again, the cosine of 30 and the sine of 60. And again, degrees, radians. Tangent and cotangent were cofunctions, okay? So again, these are complementary angles. And then you again had sine and cosine. So of course, again, secant and cosecant go together. And we had all of these up on the board, and we talked about these, and we talked about how these are going to be complementary angles. These two angles are going to add up to 90 degrees, okay? And then also back in chapter 4, at the beginning of chapter 4, we had these. And I suggested that you write these down. These were right before we talked about all of the signs, not S-I-N-E, but S-I-G-N, all of the signs in all of the quadrants. So again, quadrant 1, everything is positive. Quadrant 2, sine is positive. Quadrant 3, tangent is positive, and then quadrant 4, cosine is positive, okay? And so what ends up happening is if you take the sine of a negative angle, it's the same as the opposite of the sine of a positive angle, okay? Cosine, it's the same, okay? If I have the cosine of a negative angle and the cosine of the angle, they're the same sign. And then tangent, again, is just like sine. And this leads us into when we got to the restrictions on the domains of the inverse trig functions. These two are the same because for sine and tangent, for inverse sine and inverse tangent, our domain is restricted to negative pi halves to pi halves. And then for cosine, our domain was restricted from 0 to pi, okay? And so, again, with reciprocal identities, it's the same. Sine and cosecant, cosine and secant, and tangent and cotangent are the same. So up to this point on this page, there's actually nothing new. All that this is a nice organized way for you to look at this paper and have this in front of you, because eventually what we're going to be doing is proving trig identities, and you're going to want to know these and you're going to want to have these at the ready so that you can use them.